The next part of the session, is going to be led by Massimo Noro. Okay, Massimo Noro is going to present the winners of the ESA Phi-Lab UK cohort.
That's right. Yes. Yeah. So let's finish this off with a little bit of a celebration. Let's liven this up and a nice way to actually go into the coffee break. So my name is Massimo Noro. I'm the director for business development and business innovation with STFC. My job actually is to work alongside departments like RAL Space, ISIS, and really help translate the great science and technology they do into impact. What does that mean? It means that at the end of the day, we have to deliver on the impact metrics. And then for me, that's jobs, growth, and skills. Back to what you were saying before, Lucy. So this is what we do. In fact, we are judged on that. Of course, we have to do it together. We have to do that translation together. So let me go back one year, 12 months. I think, Sarah, you were here last time around, and then you made a promise here, so that in the 2025 edition, we'll be hear more about the ESA Phi-Lab. Well, I'm happy to say that we have delivered on that promise, and in fact, I'm here to announce the two winners, to announce the names of the two companies that will be the first two onto the program. Right. So I will call up some people from the union. It's not at random, don't worry. We have set this up so that they can actually kind of tell their own stories. But before I do that, let me just recap on what the ESA Phi-Lab is about. So why do we do it? So ESA Phi-Lab is it's a lab, essentially. It's a way to actually help these companies with a great idea to accelerate space commercialization in the UK and actually to deliver really to the economy. So essentially, it's a place where we host these applied research projects with an edge. So these are projects that are very high on innovation and high on commercialization, and we want to help them through that. Also, this couldn't be more timely because that actually aligns very well and delivers on the national industrial strategy and on the national space strategy, right? So strategy is great, but money is even better. So that's why a group of us have decided to pull together some money in terms of hard cash and resources. People is money, right? On the table, and that is the European Space Agency, UK Space Agency, thank you very much, STFC, but we also work in partnership with a fantastic consortium. And let me name check all of them really, because it's part of a great team. So they are Amentum, which is a global leader in advanced engineering. It's Cranfield University, it's Innovate UK, it's the Satellite Application Catapult, the Manufacturing Technology Center, and the Welding Institute. So together, we actually open our doors, not just STFC, but they as well. So we open collectively our doors so that these companies can access unique capabilities, right, that they cannot find anywhere else on the world. So they come, use our capabilities, and deliver something which is world leading. Money is always welcome, great, but this is not just about the money. Technology is great, but this is not just about the technology, right? We also offer to these companies kind of a wraparound business support, right? How do you sharpen your value proposition? How do you protect your IP? How do you build a business case? This is what we offer as part of our really wraparound business support for the companies that go onto the ESA Phi program UK. And in this sense, the Phi-Lab, Phi-Lab, we checked. So with a Greek speaker, it's not Phi, it's Phi, it's Phi-Lab. Otherwise, we get shot. The Phi-Lab actually sits alongside a continuum of offering that STFC does to help companies grow. And in fact, let me also name check the other program that we have in partnership with ESA, which is the European Space Agency Business Incubation Center, ESA BIC for short. So that has actually given a tremendous impact development into the UK. So in fact, our ESA BIC UK has delivered so far, helped 170 companies, created more than 1,000 jobs in the UK, and also generated, listen to this, 350 million in direct economic impact into the UK. Now, this is just fantastic, right? This is exactly what we need to do, just to deliver back to the taxpayers what is actually the worth of what the space can do for this country. Now, to date, let me go back to the ESA Phi-Lab here, and let me just say that the specific challenge that we have posed with this lab is space-enabled sustainability technologies. And the two winners, I have to say, the two winners have done fantastically well for their work in sustainability, right? So without any further ado, let me just announce winner number one. And in fact, not by coincidence, they are alumni from the ESA BIC program. Let me invite here on stage Sushma Shankar and Natalia Efronova, Deep Planet. Come on in.
Thank you very much. Very excited to be here and to be the inaugural cohort of the ESA Phi-Lab. So we will carry it with us, hopefully in a positive way, and supporting other companies on the way. So yeah, we are Deep Planet. I'm Sushma, co-founder and CEO of the company. We are a geospatial AI company, come out of Oxford a few years ago, focused on regenerative agriculture and sustainability. With me is Natalia, our co-founder and CTO, a world leader in computer vision and AI. And together we built a team in the last 7 years. In fact, we came out of ESA BIC, as was mentioned. Feels like we've come a full circle, where we started with ESA BIC 7 years ago, and now we're here to talk about our progress and the work we've done since then, and obviously also talk about the project, the ESA Phi project. So we are Deep Planet. We use geospatial AI to work with farmers, to work with corporates, to work with government entities, etc., to look at how do we optimize resources for them. One is understanding how many people to send, how to reduce labor, how to reduce sampling on the ground, to enhance productivity by improving yield, by improving the quality of the yield, not necessarily the amount of the yield, as well as build long-term climate resilience, which we think is one of the most important parts where we are focused on and doing a lot of research, understanding climate risk and how it can impact both at a field level, but also at a large-scale regional level or a national level. And so we've been very fortunate to have a number of collaborators, academic, government collaborators, but also private investment that we've raised in the last few years. And we've worked with over 80 customers now across 4 countries. And we have 2 products and a lot of research with that. So we have over 7 years of work that has gone in. Essentially, this is what happens under the hood, which is quite a very bare bones view. Our USP is the machine learning models and the foundation model that now we're working on, but the machine learning models which are specialized and focused on agriculture, right? And all of this integrates data from different disparate data sources, such as satellite data, Earth observation data, such as the European Space Agency, Planet, any other commercial satellites, millions of hectares of crop data, soil samples that we've collected over the years, working with our partners and ourselves, which has made it into a significant database on which we integrate our satellite data to provide analytics on crop health, soil health, looking at pest and disease prediction, soil monitoring and fertilizer predictions, and looking at flood and various other areas that looks at sustainability of the environment. We have over 30, this says 30, but we have over 40 or 50 specialized models, which are focused on we try to focus on customer use cases, and we deliver the analysis either on a portal, as you see, or provide API access to a lot of our corporate customers. So that's about what we've done so far. I will let Natalia talk a bit about our foundation model and the ESA Phi work that we will be doing.
Thanks, Sushma. What we propose to do is to build a very large AI foundation model for satellite imagery to be able to predict soil organic carbon on the first instance all over the globe. Why it is important? What we want to do is to provide access to the sustainability essential readings that will be available anywhere on Earth and will provide a global layer of soil organic carbon readings, essentially understanding how much carbon is there on land in any part of the world. And how we're going to do that? We have a team of amazing AI researchers that are going to look at the satellite imagery collected over the last 10 years with specifically Sentinel-2 and Landsat data, maybe expanding to other sources like climatic data, digital elevation maps, and other important features that will be used for this project. So you probably have heard about space embeddings or foundation models, and this is just a very large, unsupervised AI model that is trained solely on the data that is provided by Earth observation, and that's why this collaboration came through. So what we want to do is to train this very large model and then fine-tune it on a very, comparative to the Earth observation, that a very small sample of soil organic carbon readings that we obtain from our partners, National Trust, Alliance Wines, and Synergy India partners, and we will embed this data in our model and provide a global layer available through the portal to our users across the world. So this won't be happening without the support that we're receiving from ESA Phi-Lab, and specifically access to the compute, because foundation model is extremely computationally heavy, and it will require very good cluster, and it will require technical guidance, and obviously networking opportunities that we're getting here are incredibly helpful, and access to the cluster is also really essential for this project. So why it is useful for people? How we're gonna make this money? So first, we're gonna bring economic input. It means that we will reduce the expenses that people have on soil sampling. So they, of course, will have to do some sampling every now and then, but overall, it will be reduced very much. Also, there will be social benefit and environmental benefit that comes from the operations with the model that we pose. Yeah. So we're really looking forward to this project, and thank you very much for your support.
Thank you very much. So that is absolutely brilliant. Let's put those computers to good use and then make those predictions. So I'll see you next year over here and see how much you've done so far. Right, so now to the second winner of, the second announcement, and that is Bianca Cefalo, Space Dots.
Okay. Hello, everyone. My name is Bianca. I'm the CEO and founder at Space Dots, and it's as my previous colleagues already said, it's quite a surreal way of thinking about a full circle moment. I remember in 2022 when Space Dots was pretty much a bit of a side gig for me and my co-founders. Also, I had two co-founders. I'm the only one standing. So that says everything about running a startup. Back in 2022, it was pretty much a bit of a side gig when we decided to apply for the ESA BIC, and we got rejected. So we applied again, and eventually we made it in. And we bootstrapped the idea or the concept for the very first year with all my savings, until I called up my parents and I said, if anything goes wrong, please tell me you have a spare room, because this isn't going well. Eventually, 3 years later, we've raised more. We are a pre-Series A company now. We've raised more than £3 million. Obviously, the ESA BIC was the first yes, and you never forget your first love. That's all I can say. We are now operationally in space. We've launched our first hardware in space in January this year. And this is also another very interesting story. So what Space Dots was doing and what we're doing right now is pretty much different from what we pitched at ESA BIC. Space Dots right now is creating the first UK, European intelligence core to detect and attribute hidden threats in space. We have had amazing presentations today by Space Flux and the Met Office. And by hidden threats in space, we pretty much talk about the environment. So whatever that isn't seen. And hidden threats in space can come from space weather, can come from the harsh, obviously, environment in which we're sending our sensing systems, our spacecraft in. But some of these hidden threats can come from hostile intent, and they could be non-kinetic attacks, which are mimicking space weather, or environmental effects, which can cause anomalies or catastrophic failures on our subsystems in space. So this is what we do at Space Dots. We have our tiny payloads that are detecting data, sensing data from the environment. That's the first one that's gone to space, which, fun enough, is on the same flight as the swimmer team, which then brings us to why we're doing the ESA Phi-Lab. We fill the gap on what the data is missing on the radiation and the environment. We aggregate third-party data, legacy data. We mesh all these up, and we use in-house algorithms to predict and create pattern recognition on how the operators can actually use this information, whether it's by optimizing their design process, whether it's by optimizing their mission planning, but mainly to really understand, was this really a friendly environmental let's say, cause, or was it not? And was this supposed to be escalated at a government level? But speaking about the Phi-Lab, so what we're doing is a bit of a mouthful. It's called SEISMIC, which stands for Space Environment Information System, Miniaturized Instrument Collaboration. So this fits within the space domain awareness advancement. As we've seen, generally, what's considered as space domain awareness or space situational awareness is the debris, collision avoidance, space traffic management. But sometimes we forget that the space environment is foundational to understanding the collision avoidance, is foundational to understanding how we even choose anything that goes to space and how that safely is providing services that we are relying on a daily basis. So what we want to do is join forces with the swimmer team, and especially, obviously, the RAL space team that has contributed to the in-space space weather service. So we're joining forces to create a low swap payload. I will tell what swap means, which is size, weight, and power. And what we want to do is really to be able to create what we call it a no-regret payload, some sort of a automotive black box that you will have on any spacecraft that goes to space and provides sensing capabilities that actually understanding the context of the environment on your spacecraft, and then being able to provide intelligence that is reliant onto that environment in which we're flying. That's us, pretty much. You can find me or have more information about Space Dots with our QR code. And again, it's an honor to be here 3 years later after the first rejection and actually to build with RAL Space. Thank you, everyone.
That's brilliant. That's brilliant. Not just one, two great examples of how we deliver innovation through our business incubation and also through this ESA Phi-Lab. If you have missed this, don't worry, because we'll run another cohort in January, February of 2026. So please come back and listen, because there'll be another opportunity to actually join us in the next wave of space innovation. Thank you.